Hello, everyone, and welcome to another interesting lead code problem, which is trapping rainwater. This is a hard problem. It's kind of tricky problem, and I'll try to explain it in easy way, and I hope you will understand it. So let's start reading the prompt. The question says, given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So this is the map. Here you can see, like, you can imagine these are the hills and these are the valleys. So the water can be stored based upon what how much, like, the boundaries, the left and the right boundaries would be. So if you see on the first place here, there cannot be no water can be stored at this place. Why? Because there is no left boundary, right? So whereas at the place 1, you can see we cannot store any water again because there is no left boundary. So no water can be stored at this place as well. Whereas if we see this place, we can store water. Why? Because we have the boundary on the right side and the boundary on its left side, and according to the minimum height we can store water. So let me explain it a little bit further, and I hope I'll be able to explain it in an easy way. All right. So okay, so what I have done is, like, at the bottom I have written the height of these hills, you can say. So basically these are the hills, height of the hills, right? And whereas here, for example, there is no height. Okay, the height is 0, but whereas the height at this place is 2, and so on. And on the top I have written the index is 0. This is the 0 index, this is the first index, this is second index, third, fourth, fifth, and so on. Okay. All right. So if you measure how much water it can keep, so one block of water can come here on this place, and one block of water can come on this place. Another two blocks of water can come at this place, right? One block of water can come at this place. Okay. And then one block of water will come this place, and l- no block of water can come this place because there is no right boundary, right? So let's see how many blocks of water we can store. So this is 1, 2, this is 3 and 4, 5, and 6 blocks of water we can store. So the total value of water or the volume that can be stored is 6, right? So how we are going to proceed? What we need to do is, we will work like this. We will see the elevation. Just a second. All right, so we will see the elevation, how the graph is moving. Okay. So if in this example, if you will see, the left value is smaller while the right value is greater, so in that case I'm going to move my left pointer. This is the first thing that you need to remember, right? Whenever you will see the elevation, if this, you have to see the slope. If the slope on the left side is smaller, the pointer that you are going to move forward is the left pointer. But whereas if you will see, if you come to the point here where the left pointer is greater, then what you need to do, you need to move the right pointer, and so on, right? This is the first thing that you need to remember. Okay. Okay, the second thing that you need to remember is, if the problem was like for example, because there is another lead code problem where you will just see, like, the hills, but there is and you need to store the water between those hills. Okay. But it's not like an uneven hills where we can have heights and we cannot have heights. So solving the problem over there was easy. We will get the maximum length between the height and the width, and we can just calculate left into, I mean, width into height, and then we can calculate the water. So that problem was easy, but this problem is a little bit tricky. So the first thing is you need to remember that according to the slope, the lowest slope, you are going to move the pointers to the other direction, because that means on that side you cannot store the water, or you can store less water wherever on which side the slope is less, right? So again, as I said, that if it is like that, the slope is higher on the right side, then the pointer that I'm going to move will be the left pointer, right? And vice versa. Okay, so this is 11. Okay, this is the first thing. The second thing I told, as I was telling you, is so not only we need to keep track of left and right pointer, we need to track, or we need to keep track of left max and right max. And why we need to keep track of left max and right max? Because whenever I need to measure the water at this place, right, I need to see what is the boundary on the left side. Based on that boundary, I can calculate this cell value. If for instance I want to see if there is some water over here or not, and if I'm not keeping track of the left maximum value, I cannot find the value, like I cannot see how much value this point can save. All right, so I will explain this point again. So for instance, over here, if I'm trying to measure the water at this point, right? So this point I can measure the water based on the boundaries that are coming from each side, right? Okay, now I'm going to show you how the table is going to be updated, and then I will explain you the program, which is the program is not very tricky, but understanding the concept is a little bit tricky. So to actually, if I will write the pseudocode here, if I can write the pseudocode here so that it will be easy to understand, but I don't know how. Okay. All right. So the first thing is I'll write the steps, and then I'm going to update the values. Okay. So in this way, it will be easy for you to understand what I'm trying to say. So I need to check if left, like how much the loop should go right. The first thing is the left should be less than right thing. And so the left pointer will start from this position, the right pointer will start from this position. And I'm going to iterate until left pointer reaches the right pointer, or they try to pass each other, right? Okay, so then what I need to see, because as I mentioned you about the slope thing, right? So if for example the slope on the left, meaning the left max is less than the right max, if this will be the condition, it's just a pseudocode, but just for you to understand how I'm going to update that table and how you are going to execute it. So if left max is less than right max, then you are going to update the left pointer, right? The left pointer will be 1, and then you need to calculate the maximum of like how much is the left max. I mean to say, like for example, by this point when I will reach this point, my maximum pointer should be 1. At the starting point, the maximum pointer left max should be 0, because there is no maximum boundary on the left side, so it is 0. But when I come here, the value should go to 1, right? So this is what I need to do. I should take maximum, I should calculate left max, okay? And then I need to calculate how much water can be stored, and then how much water can be stored. So for example, I am not standing at this point. Can I store any water at this point? No, because I don't have any valley at this place. I am having the height of 1, but this one height cannot store any water. While if I go to this point and then I have the left height till here, then the water I can get the, like the height is 0, and my maximum left is 1, and the water that can be stored at this point should be 1. So then only I can find the the value of the water that can come here, right? So let's try to fill this table based on what I have explained, and I'll try to explain further when I'm explaining this table, right? So the starting point, the left pointer is pointing at this position, which is the zero index, and the right pointer is pointing at the 11, last index, which is 11. Okay, and the left max is whatever the height at this position. So the height at this position is 0, so my left max will be 0. My right max is whatever the height at this position. Okay, so this is how I'm going to initialize at the first point. Okay, so then there any water block at the start? No, there is no water block, so I'm going to initialize this value as 0. Then I'm going to check if the left max is less than right max. So the left max is less than right max, right? So if this condition comes true, what should I do? I'm going to update my left to the next position. So I'm going to come here, but I'll keep the right here. So when I'm going to come here, I'm not going to do any change to my right pointer. It will remain same, and my right max will also be same. So one of the side is going to change, the other will remain same. Okay, so I'm at place 1. Now I need to see at place 1 what is the height. The height is 1, so I will update my left maximum as 1, right? Okay, now how do I calculate how much water I can store at this position? So I will get left max, whatever the height is, minus the height at current position. I am at position this one. I'm at position 1, right? My left max is 1 and my height is also 1. So 1 minus 1 is equal to 0. I cannot store any water at this point. All right, again, I'm going to see is left less than right, but at this point, you will see I am at this point here and I am at this point here. So my left is not less than right. So what I will do, I am going to do the opposite thing. I am going to update my right pointer to this position, which is 2. In this case, when I'm updating my right pointer, my left information will remain same. This will be 1. My left max will be 1. So these things are not going to change because now we are updating on the right side and we are going to apply the same rules on the right side. Okay. So what I'm going to do first, I need to reduce the pointer, and what the value of the pointer at this will be, like r will be pointing to the 10th index, right? Because we are for a right pointer we are decreasing, for the left pointer we are increasing, right? Now I need to see the right max. Okay, so at this point my max will be value 2. Okay, because this is the maximum height or the boundary I have encountered. So I will write this as value 2, and then I'm going to check how much water I can store at this position. Can I store any water? No, because the rule is I need to subtract right max from the current height. So the current height is, I'm not writing the whole age at right position, okay? Wherever my right pointer is. So my maximum value is 2 and my height at point 10. The height is 10. So 2 minus 2 is equal to 0. I don't have any block where I can store water. Now I'm going to check that condition again. Left is less than right. So you will see that the slope is again in this direction. So I'm going to move my left pointer to this position. In this case, my left pointer will be given value 2. Right pointer will remain same, which is 10. And then right max is also remain same. I'm not going to change this value. Okay, and I'm going to calculate the value. The first thing is updating the left max. And how I'm going to update the left max, I will see what is the height at this position. So the height is 0. So whatever left max, it will remain same. it is not going to update. So the maximum boundary until this point is 1. Okay, and then I need to calculate the water that can come with the same way. I mean, left max, the idea to calculate is R max minus current height, wherever my current left pointer will be. So my left max at this point is 1, okay, and my current height is 0. So 1 minus 0 is equal to 1. So I can store one block of water at this place. So I am filling this place. I can understand that I get one block where I can put the water. Now, the next thing is you have to again check if left max is less than right max, then update the left pointer. So I'm going to go to the next pointer on the left side. So I am at the place here now. The right pointer is not going to change. I'm going to put 10 here. Okay, now the left max, if you will get the value, so it is 2. The height is 2. It means my left max pointer is going to get value 2 now, right? Right max will remain same. And then the right I mean the left max is 2 and the height is also 2, so I cannot store any water. I'm going to add 0 here. Okay, then I will check if left max is less than right max. No, then keep left as it is and decrease the right value, right pointer. So I'm going to come to this point now. Okay, now if you will see that you need to compare, first of all, whatever the height is. So the height is 1, the left pointer has to remain same because we are updating the right side. But if you see the height is 1, so the right max is not going to change, it will remain same. Okay, but when you calculate right max, which is 2, with the current height is 1. How much is the current height? It is 1. So 2 minus 1 is equal to 1. So I can add one block of water at this position, right? Then I'm going to check if left max is less than right max. No, then just keep this value here and update the right pointer and keep left value as it is. So here, when you are going to see now at which position you are at position 8. So this is the 8th position. Again, if you will see at this point, are you going to update the right max pointer? No, because it is already 2. So we will keep it like that. Now we will see, can I store water? My left max is 2. My height is 2 as well. So I cannot store any water at this position. So I'm going to add 2. Then again, you will do the same thing. Left max is less than right max? No. Then keep 3 as it is and right max will go to 7. Okay. Left max value remains same. And then we have to see, can we change the left max? Have we encountered a height more than the previous one? Yes, this is the height that is equal to 3. Okay, so I'm going to make it 3. Now the height is 3 and the right max is 3. 3 minus 3 is equal to 0. I cannot add a water here. Now, if left max less than right max, of course, left max has become. So, okay, now we need to go on this side and update this value, this pointer here. So I'm going to update my left value, which is 4. I'll keep this one 7. Right max will remain 7. It is not going to change. Now I need to see if left max, which is 2. So what is the height at this moment, which I'm at position 4. So this is position 4. It is 1. What is the value? It is just 1. So I'm not going to update my left pointer. It will remain same, but I'm going to calculate how much water I can store. So my maximum left max is 2. My current height is 1. So I can 2 minus 1. I can store one block of water at this position. So I'll get the value 0. I mean, I am going to get the value 1 here, right? Okay, so again, left max is less than right max. Make it 5. Keep this 7. Okay, I'm at position 0. Okay, so this is 0. The height is 0. So the left max pointer is not going to change. Right max pointer is not going to change. But what we are going to get, 2 minus 0, because left max is 2, current height is 0. So 2 minus 0. Okay, what is this thing? This is left max. What is this thing? This is the current height. 2 minus 0, 2. So I can store 2 blocks of water here. How much water I can store? I can store 2 blocks of water here. So I will write 2 here. Okay. Then left max is less than right max. Okay. Go to 6. Keep this 7. Okay. And this value is 1. We are not going to update the left max pointer. We'll keep it 2. We'll keep this 3. And then we need to see how much water. So 2 minus 1, it gives me 1. I can store 1 block of water. And when you will see next, if I write 7, then my loop should terminate, because left is not less than right. So this is the loop is going to end. So if you count the values, this is 1, 2, 3, 4, 5, and 6. So we have 6 blocks of water, which is the required output in the question. So let's start coding. Yeah, so the output is 6. Okay, so let's quickly write the code for it. It took some time to explain. I hope you have understood it. So the first thing is left and right pointer. The left pointer should be 0. The right pointer should be length of the array, the length of the array minus 1. Left max, okay, I will write left max comma right max is equal to, so left max, what should be the left max? It should be the value on the left side at the starting position. It should be the same, and the right is whatever the value on the right side. This is how. And there will be a variable which is result, and or I will write just result, okay, which is equal to 0. Now my first loop should start while left is less than r, okay, and then I need to check if left max is less than right max, okay. If this is the case, okay, what you need to do, you need to do 3 things, okay. First, update the left pointer, first thing. Second thing, recalculate the left max. How? Check the maximum, if left max is maximum or the current height is maximum for the left one. Whichever the maximum value, update left max, okay, and then update the result. So in result, add whatever result had already, plus here we need to do what? We need to do left max minus height, depending upon how at the left position, right? So this is for the left one. I'll just copy it, and then for the else part, I'll do same thing for the right side. So the only thing that I'm going to change, right is equal to right minus 1, and right max is equal to right max, height of right side, and result is equal to right max minus height of this one. And what you need to do, return result. Okay, let's execute it and see if it will show some error. As always, a little bit error. Result is not defined, as always, okay, uncode. Don't show me any error now. Height is not defined. Okay, the spelling mistake. Okay, all right, and it has accepted. Let's try to submit the code now. And it has accepted our code. So this is all for this problem. I hope you liked it, and I'll see you next time with another lead code problem.